Good morning. Today I'm going to go over selectively permeable membrane. So we've got a diagram here, and I'll kind of start breaking this down. We've been talking about cells, and we have a small image of a cell right there. And then there's a little square that zooms into the skin of the cell membrane. It's just kind of like the boundary of the cell, right? And we see this cell membrane kind of in a tan color, yellowish color. And it's meant to keep things on the outside of the cell from getting into the cell or from the inside outside, right? Creates a barrier. But you'll see that there's some things that span across the membrane. This is going to allow some things in and out, but the cell has some ways to regulate this. Now we're closer here where it's just one single strip of that cell membrane, and we have some of the proteins that can be found around it, and cholesterols and things like that. On this side, I have a bunch of different molecules. So these are just different chemicals, some of which can pass through the membrane and some of which can't. So let's take a look. I have 3 arrows here. And let's start with the triangle. The triangle is representing molecules that are small enough and have the right chemistry to pass through the cell membrane all on their own. This is a form of passive transport. By that I mean it's only going to move in the direction of lower concentration. So these triangles are only going to move through the membrane when there's less triangles on this side. We also have another one here. It's got a cylinder, and the cylinder is passing through this protein channel. This is also passive transport. So the cylinder is the only thing that's going to go through here. None of these other shapes can go through. It's also going to be passive because it's only going to pass to this right side if there are less of those cylinders on this right side, a lower concentration, and it'll move over there to try and balance things out. The cylinders can't pass through the cell membrane like the triangle did. Same thing with the circle, doesn't pass through either one of these. Now up here, we have the circle that's going into a different type of protein. This is going to be active transport. So this can occur no matter what the concentration is. Concentration could be low or high on this side, and this protein can take these circles, whatever molecule that might be, and only that molecule, and it'll move it from one side to the other. But it's going to require energy to go against the concentration gradient. So in my diagram here, we just have the 3 that are going across. You'll notice some other shapes here that have no way of getting across the cell membrane. So they're always going to be on the outside. Now, what you have to do to finish this up is draw and color 5 of each type that will pass through the membrane. So for instance, the circles will pass through the membrane. So I'm going to draw 1, 2, 3, 4, 5 over here. And then I'm going to color those in. The circles are going to be blue, so I'm going to color the circles in blue over on this side. You do not need to color this left side, just the ones you're adding to this side. So 5 of each type that will pass through. Some of these, based on their shape, don't pass through those 3 channels. Okay, hope this helps. Thank you very much.